Hello everyone. Now I will explain an assembly language program of hexadecimal down counter. So here to display the different count values I am using port 0. So it gives a resultant 8-bit counter. So the count value starts at FF and the last count value is 00. So it counts downward starting from FF up to 00H. Now here this is the program, and here the first line of instruction is org 0000H. This sets the starting address of the program at memory location 000H. So org is the assembler directive here. Then we have instruction move a comma hash 0FFH. This loads the accumulator with the hexadecimal value FF. So this is the starting value. And then move P naught comma A. That means the count value, it is loaded to port 0. So it is initialized with FF. Once the content FF is moved from accumulator to P naught, now initial value is set. So all the pins of port 0 are high now. Now for the next step, we have to decrement the count value. So because next value which we are going to display is FE. So use the operation decrement A. Now at accumulator, the new value will be FE. So every time when this decrement operation is performed in this loop, count value is reduced by 1. So we get FF, FE, FD, FC, etc. So all the 256 different count values we can generate using this instruction. Next, we have to introduce a delay between the decrements. So we have to use subroutine, and that subroutine name is delay and it is called using this function. So now controller goes to this delay loop, and in this delay loop we have 3 labels, up 3, up 2, up 1. So with the help of these 3 labels, now we are creating a nested loop here. So here each instruction, assembly language instruction gives the delay. So let us start with this NOP. This NOP gives 1 machine cycle delay. Next we have instruction move R0 comma hash 0AAH. Again this gives 1 machine cycle delay here. Then move R1 comma hash 0FF. For this we have 1 machine cycle delay. And again for this move R2 comma hash 0FFH, 1 machine cycle delay. Next here we have DJNZ R2 comma up 1. So this is the conditional jump instruction. Decrement the content of R2 by 1 and jump to the label up 1 if content of R2 is non-zero. So whenever this condition is satisfied here, jump occurs. So for the jump there are 2 cycles of delay, that is 2 machine cycle delay here. And if this condition is not satisfied, if it becomes false here, then there will be no jump. Therefore, it gives only 1 cycle of delay here. Next, we have other 2 conditional jump instruction here. So we have 2 cycles of delay for this. And the last instruction in this delay subroutine is return. And this return gives 2 cycles of delay. So for exact calculation of delay generated by this nested loop, we have to consider delay provided by the individual instruction and the loops up 1, up 2 and up 3. If you want to just calculate that approximate time delay, then we can simply multiply the content of R0, R1 and R2 with the delay of 2 machine cycle provided by this conditional jump instruction and divide by the clock frequency. And here clock frequency by default I have set 24 megahertz, that we can check here in the options for target. So here we can see that crystal frequency is 24 megahertz. Therefore F equal to 24 megahertz is considered here. Therefore overall delay of this loop will be equivalent decimal of this AA, that is 170, multiplied with equivalent decimal of this FF, so it is 255, multiplied with the next value FF, that is decimal of 255 into 2 machine cycle delay of this conditional jump. So 170 into 255 into 255 into 2 divided by 24 megahertz. So this gives approximate delay of 1 second. So we can say that between each decrement value there is a delay of 1 second, so that we can clearly see all the levels or all the values during the decrement operation. Next, once this delay is given, then your controller, it comes back to the next instruction after the call. So here we have return. So now controller comes to this unconditional jump back. So with this unconditional jump, your controller will jump back to the label. So here there is a label named back. So already your accumulator content is at FE now, because decrement operation is performed previously. That FE is moved to the port 0. Next, again the value is decremented by 1 with this instruction. Then again delay is introduced. Once that delay is completed, again controller comes back to the label here. So this loop is repeated many times, and all the levels, all 256 levels are displayed at port 0. So this hexadecimal counter operation is performed here, and once the last state 0 is attained, then the loop is repeated starting from FF. So here there is a infinite loop because of this unconditional jump. So this is repeated many times. So this is the program for hexadecimal down counter. Now let us simulate. Okay. Next, go to peripherals and select port 0. So this is port 0, and here we can see that P0 is loaded with the initial value of FF. Next we have to run this program. Now here we can see that count values are changing. That started with the FF. Now we are getting decrement values here. This continues up to 0, 0, and again it starts from FF. So there is an infinite loop in the program. So many times this is repeated. Thank you.